Yeah, I told you it would happen, eventually. Alright, so this is going to be a tutorial on how to solve the cube, or the 2x2 cube, using the Ortega Method. And the Ortega Method is quite an upgrade from the normal layer-by-layer attack, but surprisingly fairly easy to learn, and very few algorithms you need to actually learn, especially if you already know 2-look-OLL. So the basic idea of the Ortega is you're going to be doing it in 3 steps. First, you solve for one side, not one layer, but just one side. So if I were to solve for the blue side, it would not matter what the permutation of these pieces were, as long as there'd be blue on one side. After that, you're going to do an OLL step, or the orientation of the last layer, so you get the same thing on the opposite side. So, like these 2 sides here, blue and black, they would be both solved, just those sides. And then you'd finish the cube in one final step, the PLL, only you're going to be using PLL on both sides. Alright, so to re-illustrate that point, let me do a quick example solve here. Alright, so what I'm going to do first is solve for just one face, and this can be done usually very quickly, like 3 or 4 moves. So I see one here, and that's your orange face here. So opposite of orange is red, and that's going to be the next PLL here. So I'm going to solve for the red side using this OL. And there, red side done. Alright, and then after that, you just need to do a double PLL, and the cube is solved. A bit of a disclaimer going into this tutorial. You're going to have to note that I don't use a normal color scheme for my 2x2. I instead use a Japanese style color scheme, which is green opposite yellow, red opposite orange, which is normal, and blue opposite black, which replaces white. It's important to note this because opposite colors are very important in the Ortega, because I advise you to be color neutral when doing this method, because if you do that, then you'll be able to see very easy first sides, and it's very easy to get used to being color neutral on 2x2 as opposed to 3x3, because you don't have to do F2L, and F2L is the hardest thing to learn when you're trying to be color neutral on the 3x3. So I advise you to give it a try on the 2x2, because it'll make your times much faster. And I'm going to also assume that most cubers that are watching this have probably experienced how to read an algorithm sheet. And I posted my algorithm sheet for the Ortega Method in the description. So the only thing I'm going to make sure that you know how to read are the double PLLs, because those are a bit tricky. You'll notice that for this double PLL that I'm displaying right now, there are 2 faces being shown, a white one and a yellow one. The yellow one is the top face, while the white one is the bottom face. In this case, it really doesn't matter, though, because they're both the same. You're just going to switch the 2 pieces in the back, adjacent, and on the top and the bottom. So that's this case right here. So these 2 pieces don't need to switch, but these 2 do. Same with these 2 and these 2. So if I line it so that those switch pieces are in the back, I just simply do R2, U, R2, Y prime, U2, R2, U, R2. And that'll solve your cube. Alright, so for the rest of this video, I'm going to assume that you have a grasp of the concept of the Ortega Method, as because I'm not going to be explaining all the algorithms and going through the solves, because the solve is actually fairly easy, I'm mostly going to be giving tips on how to go fast with this method, since this is more of a speed solving method rather than a how to solve this puzzle video. So you may want to go and learn these algorithms, or have a general idea of these algorithms and like how they work right now, so you can understand the rest of this video as I'm going along. If not, just keep this in mind as I continue.